Welcome to another episode of Tutorials with Ike. Today we're going to look at another topic under business finance called risk and returns. If you are new to this channel, please do your best to subscribe so that anytime I upload, you'll be the first to see it. And make sure you share this video to your friends or your classmates or anyone that you think it would be helpful to them. Now, like I said, the topic for today is risk and returns. And let's talk about it. Now, when we talk about risk, we are going to take both of them individually. So when we talk about risk, even looking away from business finance in a normal setting, if someone says something is risky, if I tell someone I'm going out tonight and they say don't go, it's risky, meaning that it might not turn out how I expect it to be. If I tell someone I'm going to make an investment and they say no, don't make this investment, it's risky. It means that it is I might see it to be lucrative or anything, but the person is seeing it in a different perspective. The person is trying to say it might not go as expected. So that's what risk is all about. Risk is the possibility of something not going as expected, or the possibility of an investment not going as expected. And when it comes to returns, returns are something you gain from an investment or anything. If someone is saying you are getting this or your returns from this is this, it means what you are getting from it. And risk is looking at the degree or the probability of you not getting that particular thing, or the probability of you not getting the returns you are expecting. That's about risk and returns. Now let's take a look at this data for us to understand the risk and returns very well. So we have different years from 2018 to 2023. So we have 2018, 2019, 2020, 2021, 2022, and 2023. And we have the returns here. So for 2018, the return was 0.2 or 20%. So in risk and returns, if they give you the return and it's 0.2, you can just change it to percentage. You can just multiply the 0.2 times 100. That's all. If it's also 20, you can also divide it by 100. If they've given it to you in percentage and want to find it in decimals, you can also divide it by 100. So anyone they give to you should be able to work with it. So for 2018, they said the return was 0.2, which is the same as 20%. It means I made an investment and they've not given us any figures. So let's assume it's 1,000 cedis. Let's assume for all of them, it is 1,000 cedis. And in 2018, that 1,000 cedis, I made an investment and the return, and I said return is something you are getting or what you are getting from it. So what you are getting from it was 20%. So if it's 1,000 cedis, if I want to know what I got from it, it's just going to be 20 over 100 because it's 20%. So this 20 over 100 times the 1,000. So you can cancel the 0, 0 cancel 0. This 0 to cancel the 0. So we have 20 times 10, which is 200 cedis. So we invested 1,000 cedis. And our returns, when we solved for it, we got 200 cedis. Meaning that at the end of the day, what you are getting is 1,200 cedis. So you add the return to the 1,000 cedis, then you know what you got. So I made an investment of 1,000 cedis, hoping to get something. And I got 200 extra, which was my return. So the 200 is my return. So 1,000 plus 200, and now I'm getting 1,200. So that's how you interpret this. So yes. So for 2018, assuming it was 1,000 cedis I invested and I got 20%, it means I'm getting 1,200. That's for 2018. And for 2019, our return was negative 0.18, which is the same as negative 18%. And anytime you see a negative return, it means you didn't make any profit. You rather lost money. Anytime you are making an investment, you can't always predict it. Sometimes it might not go as planned. So for this one too, if you invested the same 1,000 cedis, it means it's going to be it's negative 18%, so negative 18 over 100. Because percentage is always over 100, and we multiply it by the 1,000 cedis. Because I'm just using 1,000 cedis, it can be any figure. So we can just do it simply on the calculator. So you have negative 18 over 100 times 1,000. And we get negative 180. Remember, we invested 1,000 cedis. Remember, you invested 1,000 cedis, and our returns was negative 180. Meaning that what we are going to get, the negative 180, we take it from the 1,000 cedis. You get it? So we get 1,000 minus 180. And let's do 1,000 minus 180 and see what we get. So we are getting 820. So it means in the second year, we made an investment. We didn't know that we were not going to make profit, but we ended up getting a return of negative 180, meaning we are subtracting it from our 1,000 cedis, and then we are getting 820. So now from 1000 cedis to 820, that's all about return. So it's the same thing for all the various years. So for 2019, negative 0.1, it's meaning it's a negative return. 2020, 0.08. So you just do 8%, 8 over 100 times whatever figure they give you. So if it's 1000 cedis that you invested, if it's 10,000, 100,000, 1 million, 1 billion, anything, then this one you have 0.14, which is the same as 14%, 2020 0.08, which is 8%, and 2022 0.2, which is 20%. So the data here just tells us the returns for each of the various years. And if I'm investing at a company and I want to see if it's a good idea to still invest or I'm wasting my money, I can calculate for the average return. The average return will tell me the returns I'm earning averagely. It's just like you're in the class and at the end of the semester, the examination results come and you want to calculate the average marks for everyone. So maybe this person got 90%, another person got 100, another person got 80, and you want to see the strength of the class. You can calculate for the average marks to see how well, the class is doing, or if the class is actually intelligent, or if there are lots of intelligent people. So the same way, you can also calculate the average return for this to see if your investment is good. Let's say 2018, I invested into this business, 2019, I invested into this business, 2020, and I'm investing over a period of time, and I want to see if it will be a good idea to invest there or I'm just wasting my money. So I can calculate for the average return. And if you want to calculate for the average return, you just sum all the returns divided by the number of it. It's just like we are three people, you want to calculate maybe our average age. If let's say this guy is 10 years, another guy is 11 years, there are two people, 10 years and 11 years. I want to calculate the average. It should just be 10 plus 11 over 2. If there are three, one is 10, another is 11, and the other is 12, it's just going to be 10 plus 11 plus 12 over 3 because there are three people. So for this one too, we are going to add all the returns divided by the number of returns. So let's start. So we have 0.2 for the first one, and then the second one we have plus 0.18. So you can just say negative 0.18 because plus a negative, it will give you negative. Then plus 0.08 plus 0.08. Then the next one, which is 2021, plus 0.14 plus 0.14 plus 0.08 plus 0.08. Then the last one, which is 2023, plus 0.2 plus 0.2. Then we count them. So 1, 2, 3, 4, 5, 6. Then over 6. So you just add all the returns, 0.2, negative 0.18. And anytime you see a negative return, make sure you subtract it, not add it. If you add it, your total answer is going to be wrong. So make sure you always subtract it. So minus 0.18, then plus 0.08, then plus 0.14, then plus 0.08 again, then plus 0.2. So you add all the returns, then you count the number of returns, which is 6, so over 6. So let's do it on the calculator and see what we are getting. 0.2 minus 0.18 plus 0.08 plus 0.14 plus 0.08 plus 0.2 over 6. So we are getting 0.08 or 0. So you can just do 0.09. 0.09. So it means our average return is 0.09. So let me just write it so that So what we just calculated is called the average return, which is 0.09. So if you are given a data you want to calculate for the average return, or the question demands you to calculate for the average return, you just add all the returns over the number of returns. Now you get 0.09. You can also change it to percent. So it will be 0.09 times 100, which will give you 9%. So our average return is 9%. What this means is that for all the returns you have here, the return you got for 2018 to 2020, averagely, the return will give you 9%. Meaning that if you invest, you are likely to get 9% for most of the returns. But don't get confused with the average return, because the average return doesn't really tell you everything about it. It just gives you an average. For example, if I go to a class and everyone is earning, let's say 100%, and I go to the class and I get like 2% or 3%, and you add me to the average, so you add me to those who already got 100%, you're likely to get a very high number, even though I didn't do well. So sometimes you can actually get like a high average return, but then the returns, this one like this, there was a negative return, but then the average return was positive. So you might easily be deceived that, oh, all the returns are actually giving you like a positive result. You get it? So the average return just gives you, I mean, an average, but not really how well all the returns are going to give you. Now remember, this 9% is just an average. It doesn't really give you the actual result you want. If let's say in Ghana, they say that maybe the average salary of a Ghanaian or the average wealth of a Ghanaian is, let's say, 100,000 Ghana cedis, it doesn't mean everyone is getting 100,000 cedis. Someone might be getting 20,000 cedis, someone might be getting 1 million Ghana cedis. I mean, it can vary, but because maybe a lot of people are doing so well, the average rises. You get it? So this one, because of perhaps the high ones, like the 20%, and the 20% also, it's raised the average return. So you want to see how the other returns or all the returns deviate from the average return. I don't know if you get it. So I'm going to use the other example I used. Let's assume I'm in a class here. Everyone is doing well. Everyone is getting 100%, 80% in the exams. Everyone is doing so well. And I join the class and I even get 2%. If you calculate the average for the class, it will still be a very high mark, despite the fact that I'm not doing well. Do you get it? So it's the same concept here. Some of the returns might be so high, so they raise the average return to the point that you might easily forget about the negative return. So now I'm going to calculate for the risk, and the risk shows us how each of the returns deviate from the average return. So if it's, let's say, Ghana like this, and they say maybe the average salary is 50,000, and someone comes, oh, 1,000 cedis, you want to see the difference between the 1,000 cedis that the person is getting and the average salary of a Ghanaian or the average income of a Ghanaian. This one too, you want to see how the average return deviates from the actual return. This one like this, they are saying the average return is 9%. So under normal circumstances, it should mean that almost every year you should be getting around 9%. But this same thing, you are getting negative 0.18. So you want to see how each of the years deviates from the average return. And if you want to know how each of the various returns deviates from the average return, it's the same as finding the risk. So the next thing, you want to see how risky is it. Looking at 0.2, negative 0.1, it's like all the returns, how risky is it for me to invest the next year? And there are two approaches when it comes to that. When it comes to determining how the returns deviate from the average return or determining the risk, is the same thing. So the first one is the variance, and the second one is the standard deviation. Now let's explain it. I'll explain all of them. So the formula for the variance is so variance is equal to, so it's something similar to this. So this is the symbol. So if you see this thing, it's the same as variance. If they don't say the variance, it's the same. So the formula is 1 over n minus 1. So 1 over n minus 1, then times sigma into brackets r. R is the return, then r bar. R bar is the expected return squared. So the variance is equal to 1 over n minus 1 times sigma into bracket r minus r bar squared. Now let's break down the formula. So 1 over n minus 1, n is the number of years or the number of investments you are making. So for this one, it was 1, 2, 3, 4, 5, 6. So n is 6. So n is just the number of returns or the number of investments. Then sigma, anytime you see sigma, it means sum or the summation of, then into bracket r. R is the return. So for 2018, the return was 0.2. So if you are calculating for 2018, it's going to be 0.2. For 2019, the return was negative 0.18. You don't use the percentage, you use the actual return, not in percentage. So for 2022, the R is going to be 0.08. And the expected return or the average return is what you solved for and we got 9% or 0.09. So that one is constant, it doesn't change. But the average changes every time you are solving, depending on the year you are solving. But the R bar is the expected return or the average return. That's what we solved for previously. Then everything into brackets squared. So now let's explain the concepts of the variance. So like I said, the variance is used to calculate or determine the risk or to see how the actual returns deviate from the average return, the one we just solved. And if your variance is high, assuming we solve for any value and it is very high, it means that the probability of these things or these values changing or they not being what we expect is very high. Do you get it? It means if, let's say, we got 9% as our expected return, it can go very, 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 very high or very, very, very low. It can be either very high or very low. But if our variance is low, it means it's likely to be what we expect. That's what it means. So the higher the variance, the higher the risk. The lower the variance, the lower the risk. That's basically what it means. So now let's solve for the variance. So the first thing we are going to do is you are just going to repeat every single thing here. So all the values here, let's just repeat it. So we have the year, which is 2018, 2019, 2020, 2021, 2022, then 2023. We are going to repeat the returns as well. Then the return. So we had 0.2. There's no need to write it in percentage because we'll not use it at this point. Then we have for 2019, we have negative 0.18. Then for 2020, we have 0.08. Then for 2021, we have 0.14. Then for 2022, we have 0.08. And for the last one, which is 2023, we have 0.2. So now this is what has been given. Now the first thing we are going to solve for is the R minus R bar. We need to solve for that before we'll be able to get a squared. So what is R? R is the return here, and R bar is what we solved for previously. So let me just put it here. So R bar is the 0.09, what we just solved for. So the R here is 0.2 minus 0.2, which is the return for 2018, then minus 0.09, which is the R bar. So the R bar is going to be the same thing, 0.09 for all of them. Then it's equal to, so let's solve. You guys can also do it so that you guys follow up. So 0.2 minus 0.09. So you're having 0.11. So you're having 0.11. Then for the second year, which is 2019, we have negative 0.18. So the return minus the expected return. So minus 0.09. Then let's do it on the calculator and see what you get. So you have 0.18, sorry, negative 0.18 minus 0.09. So you have negative 0.27. Negative 0.27. Then we move on to the next one. The next one, the return is 0.08, as you guys can see here. So 0.08 minus the expected return or the average return, which is 0.09. So let's do it. 0.08 minus 0.09. We're getting 0.01. Sorry, negative 0.01. Negative 0.01. Then for the 2021, we have the return, which is 0.14 minus the average return, which is 0.09. Then we are getting, so 0.14 minus 0.09. We're getting 0.05. 0.05. Yes. Then for 2022, we have the return to be 0.08 minus the average return, which is 0.09. So let's do it. Okay, so we have the same thing here. So you don't need to do it again. We have negative 0.01. Here it was 0.08, so we'll need to do it again. Then for the last one, we have 0.2 minus 0.09, which is the average return. So here too, we had 0.2, 0.2, so we'll need to do it again. So 0.11. So if the returns are the same, you will not need to do it over again, because I mean, it's the same thing you are solving for. So now we've calculated the return minus the average return, but remember we are supposed to get the return minus average return, the square of it. So we'll have to square the values we just got. So right now, this is going to be return minus average return. So the square of what we just got. So the first one was 0.11. So we'll just square 0.11. So everything we're about to do here, oh, sorry, I didn't bring the square. So square. So everything we're about to do here is just the square of the values we've got here. The square of the values we got here. So 0.11 squared is 0.0121. 0.0121. Then negative 0.27. Negative 0.27 squared. So negative 0.27 squared, we are getting 0.0729. 0.0729. 0.0729. Then the next one, which is negative 0.01 squared. Negative 0.01 squared. Then we are getting 1 times 10 exponents negative 4. So if you get, let's say, a number in a standard form, let's say 1 times 10 exponents negative 4, you have to change it to figures. And to change it to figures, it's just you're going to start like this. So 1, 2, 3, 4, then point 0. So 0.0001. You get it. If it's negative 4, most of the time it's going to be exponents negative 4. So if you get this one, we got 1 times 10. So you start from here where the 1 is. So 1, 2, 3, 4, then point 0. So you get 0.0001. So 0.0001. Now the next one, which is 0.05. So I'm going to square 0.05 square. We are getting 2.5 times 10 exponents negative 3, which is the same as 0.0025. 0.0025. Okay, so the next one is the same as this one. So what we squared here, the same thing we are squaring this. So 0.0001. And the next one is the same as this one. So the same thing we got, 0.0121. I hope you guys are not confused. This and this are the same. This and this are also the same. So you can just repeat the values. Now the formula says you should find sigma into brackets r minus r bar squared. So you find r minus r bar squared for each of them. So you're going to sum everything. So let's add all of them. The first one is 0.0121. The second one, 0.0729. And the third one, 0.0001. And the fourth one, 0.0025. And the next one, 0.0001. And the last one, 0.0121. So we are getting 0.0998. So it means when we add everything, we got 0.0998, which is the same as sigma r minus r bar squared. So now we can actually find for the variance. So the variance is 1 over n minus 1, which is here. So 1 over, so the variance. So 1 over n minus 1, and n is the number of years, and the number of years is 6. So we have 1 over 6 minus 1, then times sigma r minus r bar squared. Here is the same as sigma r minus r bar squared. What you just solved for is the sigma r minus r bar squared. So 1 over 6 minus 1 times this one, which is 0.0998. So let's see what you get. You have 1 over 6 minus 1 times 0.0998. You are getting, so you are getting 0.01996. So this is our variance. So our variance is 0.01996. Now what does this mean? If let's say we are solving for different investments, assuming sometimes they'll give you maybe stock A, stock B, stock C. So when you take all the variances, if let's say for stock B, let's assume this is stock A and we got 0.01996, then stock B we get something like 0.2 or 0.3. 0.3 is actually higher than 0.01996, meaning that for stock B, which is 0.2, assuming it's 0.2, It means that one is more riskier than this particular one. If you also get, let's say, 0.0003, or maybe it's just 0.01, it's less than this one, meaning that this one is more riskier. So the higher the variance, the higher the risk. But when it comes to the variance, it's a little complicated, because for this one like this, we got 0.01996. Assuming we had like a different investment and we got 0.01236 or something, is the values are a lot, so it makes it a bit complicated to see which one is higher or something. So because of that, we use the standard deviation most of the time. The reason is that the standard deviation is usually measured in percentage, so that one you can easily understand it. Now let me give you an example. So this one we have the variance to be 0.01996, and you know the standard deviation is the square root of the variance. So let's find the standard deviation of this. So there's no space, but let's just manage the one here. So for the standard deviation is the root of the variance, which is 0.01996. So anytime they give you the variance and you want to find the standard deviation, you can just find the square root of it. That's all. So let's find the square root of this 0.01996, which is the one I've done here. So we are getting 0.14. Yeah, 0.14127. But I can to two decimal places, you can do 0.14. So the standard deviation is 0.14. And you always multiply by 100. So 0.14 times 100. I hope you guys can see. And you are getting 14%. 14%. So for this one, look at how complex it was, 0.01996. And the standard deviation are just giving us a simple value in percentage. So assuming we solve for another one, a different investment, and we get maybe 14.7%, 20%, 30%, 50%, I mean, that one is more riskier than this. And if you also solve for another one and you get 7%, 5%, 3%, it means this one is actually more riskier because this one is higher. So the same thing, the higher the standard deviation, the more riskier it is. So in case in exams or something, they give you like different investments and they ask you to find which one is more riskier or which one is less riskier, you just check the standard deviations. It's better to use the standard deviation. Now, when you find the standard deviation, if let's say one of them you get 14%, another one you get 21%, the higher one is more riskier. So you say that one is more riskier. If let's say you get 7% and 14%, the 40% is more riskier because it's higher. So that's basically about it when you are determining risk. Okay, so moving on, we have another question which is quite different from the first one. So for this one, they've given you stock A and stock B. So there are two different investments. So you can also see investment one and investment two, two different ones. So if you are making an investment, there are three things that are going to happen. We have the excellent, worst, and the normal. So the excellent is a situation where your returns are way more than you expected. Maybe you invested 1,000 cedis into something, you're expecting, oh, maybe 1,200, 1,300. But all of a sudden, you got like 2,000, 2,500. Like, it's way higher than you expected. That's for the excellent. Now, the worst is obviously you getting like what you're not expecting. So maybe you invested 1,000 cedis. At the end of the day, you thought you get 1,500. But you ended up getting like 800, 700, or even losing everything. That's the worst. And we have the normal. The normal is what you expected. So maybe you invested 1,000 cedis, you're expecting 1,002. You get what you're expecting. So that's basically it. Now for this one, so they've given us the probability, making it a bit easier. So the probability is the likelihood of it happening. Now for the first one, it was excellent, meaning that our returns is going to be way more than we expected. And they said the probability of that happening is 0.4. 0.4 is the same as 40%. So 0.4, if they give you the probability, you can just multiply times 100. So you can do 0.4 times 100. You're going to get 40%. So the probability of you getting an excellent or you getting a return of 0.32, 0.322, you multiply times 100. So you get 32%. The probability of you getting a return of 32% is 40%. I don't know if you guys are getting it. If you guys are confused, you can just, the return is 0.32 here. So for the first one, the return is equal to 0.32. And 0.32, you can change it to percentage. So you get 32%, which is 0.32 times 100. 0.32 times 100. You are going to get 32%, just like that. And for the probability, you have 0.4. So it's also the same as 0.4 times 100. So you get 40%. So it means Our return for the first one was 32%, and the probability of it being, or the probability of the return being 32% is 40%. The probability of the return being 32% is 40%. And 32% is considered excellent. If let's say you're investing 1,000 cedis and you're getting a return of 32%, that's actually very high. So we say it's excellent. So the probability of you getting an excellent outcome or an excellent return, which is 32%, is 40%. That's what it means. So the probability of you getting a return of 32% is 40%, which is very high. And the next outcome is the worst. So for the worst, the returns was obviously negative. So negative 0.05, which is the same as negative 5%. And the probability of you getting an outcome which is not, desirable, which is like the worst among all of them, is also 40%. You get it? So it means the probability of you getting an excellent one is 40%, whereas the probability of you getting a worse one is also 40%. That's what it means. Now the third one, normal. So normal is what you are expecting, not too high, not too low, just what you are expecting. And the probability of you getting it is 20%, which is 0.2. So 0.2 times 100, 20%. And the returns is 0.21. So that's what you're expecting. So this one, the person was expecting 0.21 or 21%. So they are saying the probability of he getting what he expects or he getting a normal outcome is 20%. That's what it means. So it's the same thing for stock B. And the question says that we should calculate the expected return for each stock. So the expected return is the same as the average return. Mind you, the stock A is just one investment. These are just different outcomes. It's just saying the probability of you getting either a good result, a bad result, or a normal result. So it's saying you should calculate the average, what you are going to get based on these probabilities. It's like you're going for a competition and there are three different people telling you different things. One person is saying you're going to do very well, like exceptionally well. Another person is telling you that your performance is going to be terrible. And the last person is telling you that your performance is going to be moderate, like normal, as you are expecting. You get it? So now, based on what they've given you, you want to see what you're actually going to get, like averagely, based on their commentary on it. So based on the returns they've given you and the probability for them, you're going to see what you're actually going to get, or the average. So for this one, the average is not like the first one where you add all the returns and divide it by the number of them. This one, the average is the first return. So the first return is 0.32 times the probability, 0.4. Then plus the second return, which is the worst, which is negative 0.05 times the 0.4, which is the probability for that one. Then plus the last one, which is 0.21 times 0.2. Let me write it so that you understand. The first one is excellent, which is 0.32. So we have 0.32 times, so 0.32 times the probability, which is 0.4. So we are done with the first one, the excellent. And now we move on to the second one. The second one is the worst. We have negative 0.05. So it's no more plus. So negative 0.05. So anytime there's a negative, you don't add, you subtract. So that's negative 0.05 times the probability, which is 0.4. So times 0.4. Then the last one, 0.21 times 0.2. So plus 0.21, 0.21 times 0.2 times 0.2. So let's punch it on the calculator and see what you get. So we are getting 0.15. 0.15. So when you get your 0.15, you can multiply times 100 and you're going to get 15%. So what this means is that our average return or our expected return is 15%. This one, they just give you what you are likely to get. If your return is going to be good or is going to be bad or is going to be what you're expecting, they are just giving the probability of you getting those ones. But the average return is just giving you one outcome, what you're actually likely to get based on the various probabilities. So that's for the I. So that's the expected return or the average return. Now we move on to the II. The II says calculate the total risk of the client's business for each stock. The total risk. And I said there are two ways of calculating risk. The first one is the variance, and the second one is the standard deviation. But mostly we use the standard deviation because that one is more effective. So we are going to use the standard deviation. So this one, the expected return, we've got 15%. So you can claim it. Let me just write it then. So expected return or the average return equal to 15%, or or you can say, or 0.15. Yes. And I said there are two ways of calculating the risk. The first one is the variance, the second one is the standard deviation. But it's better to use the standard deviation. So we are going to find the variance, then we'll also find the standard deviation. And this one, the formula for the variance, when it comes to only this one, when they give the probability, is, so we have the variance is equal to, we have sigma into brackets, we have p into brackets r minus r bar squared, and close it. Yeah, so this is the formula for the variance when they've given the probability. So this time you introduce the probability. So you multiply the probability by this. So let's break it down. So let's solve for stock A. So for stock A, the returns we have, um, the first one we have 0.32, 0.32. The second one, negative 0.05, negative 0.05. And the last one, we have 0.21, 0.21. So now we have the returns. And the second thing we are going to look at is the returns minus the expected return, because we'll need that for the formula for the variance. So return minus the expected return. And the expected return is the 0.15. So anytime you see R bar, is the expected return or the average return. Yes. So R minus R bar. So this is the R. So we have 0.32, 0.32 minus the R bar, which is 0.15, the one we solved for. So 0.15. And what are we getting? So we have 0.32 minus 0.15. We have 0.17. It's equal to 0.17. And the next one, we have negative 0.05, which is the R, negative 0.05 minus the expected return, which is 0.15. So we have negative 0.05 minus 0.15. We're getting negative 0.2. Negative 0.2. Then we have 0.21. Okay, so let me write it first. So 0.21, which is the R here, minus the expected return, which is 0.15. So 0.21 minus 0.15. Yeah. So 0.21 minus 0.15. We are getting 0.06. So 0.06. So these are the values for the R minus the R bar. But for the formula, we have to find R minus R bar squared before we multiply times P. So let's do that. So since you guys have seen the process, we can just clean it and write the values there. So for the first one, it was 0.17. So let's just clean it and write it there. So 0.17. And the second one, negative 0.2. So for space, you can just, so negative 0.2. And the last one, 0.06. So 0.06. Now R minus R bar squared. So R minus R bar squared. So you are just going to square what we have here. So the first one is 0.17 squared. We have 0.0289. 0.0289. And the second one, 0.2 squared. Sorry, negative 0.2 squared. We have 0.04. 0.04. And the last one, we have 0.06 squared. So 0.06 squared. So 0.06 squared. We have 3.6 times 10 exponents negative 3, which is the same as 0.0036. So we are done with the r minus r bar squared. Now we are going to look for p times r minus r bar squared, because that's what the formula demands. The formula demands the sigma of p into brackets r minus r bar squared. So the probability, okay, we have to add the probability. So let's add the probability. So for the first one, it was 0.4. 0.4. The next one, 0.4 as well. And the last one, 0.2. That's for the probability. So now I'm going to find p into brackets, exactly what is here. R minus r bar squared. So p into brackets r minus r bar squared. And what do we get? So for p, you have 0.4. So this times this times this, and this times this. So 0.4 times 0.0289. We have 0.01156. 0.01156. Then in the next one, you have 0.4. So p times r minus r bar squared. So 0.4 times 0.04. You have 0.016. 0.016. And the last one, we have 0.2. 0.2 times 0.0036. We have 7.2 times 10 exponent negative 4. So when you change it to figures, you have 0.30, 0.00072. Now we found the p into bracket r minus r bar squared, but the formula demands us to find the summation or the variance. So we have to add all the values here. So the summation of this plus this plus this. So we have 0.01156 plus 0.016 plus 0.00072. So we are getting 0.02828. 0.02828. So straight away, this is our variance, because the formula says variance is the summation of this. So we can say variance is equal to, so this one, 0.02828. But it's better to use the standard deviation to determine the risk. So for the standard deviation, I'm going to find the roots of the variance. So standard deviation, or SD, is equal to square root of the variance, which is 0.02828. So anytime you find the variance and just for the standard deviation, you find the square root. So we have root of 0.02828. We're getting 0.168. So you can just say, so let's say 0.168. Or let's just do a 0.17. 0.17. 0.17, then we always multiply times 100. So we are getting 0.17 times 100, which is 17. So 17%. So we are getting 17%. So assuming we solve for stock B and we get maybe 21% or 30% or anything higher than 17%, it means stock B is actually more riskier than stock A. But if you solve for stock B and we get anything less than 17%, say 9%, 7% or anything, it means stock A is actually more riskier. That's it. So the higher the variance or the higher the standard deviation, the more riskier it is, and vice versa. So that's basically about it. So you guys can solve the stock B and let me know what you guys get in the comment section. And if you guys don't understand anything, just let me know in the comment section. And that will be all for today. I'll see you guys in the next video.